Hi, my name is Mark Dunston. I am a membrane technologist for Hydrite Chemical Company. I have the wonderful opportunity in this job to work in development of next generation tools and chemistry from a perspective of testing what really works in the field by operating on the production floor of producers who use membranes, as well as working along with our chemists, equipment team, and many of the manufacturers of membrane elements and membrane systems. I am going to talk to you today about a concept called soil load mapping, abbreviated SLM, or SLM as we like to call it. With the ongoing opportunities to optimize clean-in-place procedures for our customers, we have designed this program to help manage the risks associated with identifying and implementing new procedures that save time, water, and energy, and have even surprised us by having many other unexpected benefits. Now, it's hard to see inside a membrane system to know exactly how well it's cleaning. And even if a visual inspection were possible, there's no easy way to observe when and how well molecular foulants are removed from the microscopic pores throughout the membrane elements in a system without intensive analysis. There has been considerable changes to upstream processes for many applications, especially in the dairy industry, with improvements on fine removal, separation, and pre-filtration, and many other enhancements. But many of the cleaning procedures in place since these developments have not been significantly changed. While there have been considerable studies on the theoretical optimum for circulation during wash steps in the lab, such information often goes unproven in the field. This means there is potential for many overlooked savings opportunities through better management of time, water, energy, and other CIP resources. Now, the benefits of optimizing CIP are usually targets of many of the continuous improvement initiatives seen in the industry. The biggest ones I hear consistently involve better water management and quicker CIP turnaround. But there are plenty of other incidental benefits to CIP optimization on membrane systems, such as extended membrane life due to less chemical stress, or freeing up operator time to be allocated to other important tasks. Now, there are good reasons why there is not a stronger push for optimization where membranes are concerned. Not only are there more often urgent objectives to deal with when it comes to facilities with membrane units, but taking on optimization projects can be daunting, and the potential of a failed wash with a poor production following may make changes to an important piece of equipment less than appealing. Unlike a lot of the hardier equipment in the production plant, membranes that are not cleaned correctly may accumulate irreversible fouling or be exposed to excess hydraulic stress if not properly cleaned. So even if the opportunities are high reward, they come at considerable risk. On top of that, when it comes to analyzing the efficiency of the wash, it's not very feasible to open a membrane after each CIP and test for variation in what microscopic foulants we are dealing with, though there may be a couple of companies at this event who would happily sell you another if you wanted to. Additionally, the impact of an incomplete CIP may not show up immediately. The cumulative effects of incomplete foulant removal may not fully manifest in a measurable way until weeks after a change is implemented. So trialing a CIP change based on even just a good hunch might not always pan out, and again introduces some level of risk. Inline CIP measurements can be useful, but as with all equipment, it comes with upfront capital costs and long-term upkeep, if installed. There is also the variability in processes on equipment. One day you may be making WPC 34, but if you do WPC 80 the next day, or open additional loops, or target different solids based on the rest of the facility's equipment, the amount and type of soil on the membranes can change. So to cope with this, CIP procedures often have built-in margin cleaning capacity to handle the largest variable soil load that is expected on that unit. Because of this, without real investigative tools, it's reasonable that much of the industry maintains an attitude of, if it ain't broke, don't fix it. There's a phrase that's been thrown around when it comes to membrane cleaning, that it's more of an art than a science. But that phrase has been used in other fields of knowledge before new information was made available to understand a more complete model that includes what were originally thought to be anomalies. When we begin to gather additional information related to how membranes foul and clean, it becomes more and more clear that the reality is simply that the full picture involves levels of nuance which, once known, can be used to more specifically understand not just what happens in the lab, but what happens in real-life operations. Hydrite is committed to bringing a more scientific approach to membrane cleaning through better understanding of CIP. The aim of this approach is to be able to give our customers something more than an off-the-shelf program, but to produce a custom CIP program for each system and produce a process that uniquely and successfully deals with the way that a particular membrane system is followed during operation. So from that goal, this idea emerged to measure the soil load that accumulates in a wash solution as a sort of reciprocal of what is being removed from the membrane surface. The advantage of measuring the soil in solution is that it is rapid and indirect, so that it does not require any invasive or disruptive opening of the system for autopsy to give useful information. We can also be picky about what information we are looking for to modify and target sampling resources to be specific to actionable information. Information that would be worth the effort of modifying the CIP program to achieve more efficiency. As much as a nerd like me is curious about efficiency for efficiency's sake, the reality of the resources and people necessary to make a change to the CIP program on a membrane system often inhibits making every change at once, and knowing what improvements would immediately be worth making changes allows studies to focus on finding those opportunities. For example, if a plant is primarily concerned about reducing water consumption, there's not going to be much enthusiasm to cut 10 minutes off a wash step recirculating the same wash solution for a system that has already extended downtime before its next use. But if there's a step on that system that can be eliminated, it makes sense to execute that change to save the water involved. The other thought that is built into the SLM platform is the concept of comparing soil removal before and after a change. We want to be able to quantify that the same foulant being removed on the original program are still being removed after efficiency improvements are implemented. Pretty much as soon as we took this tool set to the field, we began to see opportunities to reduce the resources needed to complete a successful CIP. It is exciting to be able to demonstrate with hard data that a particular wash step can be shortened or sometimes eliminated without impacting the outcome of a CIP. And being able to identify those opportunities up front allows for this to happen without investing any significant risk in the operation. While reducing CIP time is nice, eliminating steps is where they are not needed is where significant water savings get realized. And even if the first pass does not immediately show a reduction opportunity, sometimes the information might show a better order of wash steps or chemistry addition that will potentially open the possibility of future optimizations. And even if no opportunities are revealed, it can be useful to use SLM just to verify that the most efficient program is already in place. All this is possible because we are looking to see exactly how things are currently cleaning to make an evidence-based decision on how a system can clean up best. For a large cheese producer, Hydrite was able to use SLM methods to identify optimization opportunities on a large number of their membrane systems. Right off the bat, we were able to save a lot of time. We also made a significant dent in helping them towards achieving their water use reduction goals. And these changes actually reduced the overall chemical spend to clean on these systems. Besides just seeing the obvious reduction in resources committed to a CIP, or demonstrating a modular capacity to handle greater throughput with the same capital, we were also able to show, through predictive testing, where theoretical opportunities to remove or reduce certain wash steps would actually cause problems if they were removed. So this prevented trying things that would work on one system but not on another. Instead of just giving a cookie-cutter high-efficiency program, we were able to tailor programs to specific equipment and processes that were really the highest efficiency for that particular unit operation. The way that Hydrite has set out to do this is by measuring what we like to call soil load, which is basically the amount of foulants removed into a cleaning solution. By sampling of target soil markers throughout a wash, we are seeing when the soil load of a particular wash stops climbing. And then, by combining it with other CIP monitoring information to understand why, we're able to produce a sort of map and make recommendations on how to improve the CIP in a particular system. The advantage of using this method is that it is non-invasive, repeatable, and rapid. The information we get back tells us where the opportunity exists, and we share that with the customer to make changes in a low-risk way. This again goes back to having the ability to come up with optimal cleaning procedures for a piece of equipment based on what product has just been run. We can see here on this map how there are portions of the wash where not a whole lot is changing. Even better, there are portions of the wash where no soil ever begins circulating in the wash. This is the type of information that we can use to recommend changes in an evidence-based way that removes substantial concerns about changing a successful program. So in the example, based on the evidence, we can remove that wash step without impacting the success of the wash. Once we have that information, we can detail the specific recommendations that will both help that membrane system operate at its most efficient and be compatible with targeting the objectives that are most important to the producer. From there, we look to trialing those changes and assessing the statistical stability of metrics that are important to the producer. Information that will put our finger on the pulse of how this machine is working. If performance improves or is maintained over a target time frame, we can validate the change as successful. And if further confirmation is needed, additional SLM testing can be done to assess the soil load differences between the previous and new CIP program, so we can know that we are removing the same soils we were removing before the change. Now this helps with multiple things from the producer perspective as far as creating the best CIP on a given unit, but it also allows an opportunity to understand better how industry best practices really stack up. By comparing process information on the various tests we have conducted with SLM, we can see metadata trends that outline better practices for cleaning membrane systems of a particular size, element type, and process to improve the industry as a whole by more efficiently using resources and still achieving the best possible cleaning. Here's a graph of a particular type of wash removing a particular kind of soil using a similar process on multiple systems. The trends that develop from the information gathered help to influence the next generation of best practices so that information learned on one test can improve multiple processes and increase the knowledge base and understanding of membrane cleaning. I hope this presentation has been interesting. I would be happy to answer any questions that you would have about it at this time. Thank you. So I'm going to go ahead and answer a couple of the questions that we have about SLM and membrane optimization. So first off is, what is the cost of doing this? As far as pricing, right now, Hydrite is incorporating this into our service model. We use this with our customers to optimize their processes as a priority. So it's not something that we're independently pricing. It's part of our service package, just to bringing the best solutions to our customers. Can this be done on equipment other than membranes? That is a great question. We are currently testing for the best ways to use it on other pieces of equipment, especially other equipment that's connected to other CIP loops. And there's going to be some variances between how it gets used on a membrane system. So we're not pushing that as an offering at this time. It is something we're investigating, and I think it's very promising that we will be able to offer this on other types of equipment. But at this time, because membranes are one of the biggest opportunities for optimization in the plant, that's where we're pushing this expansion into understanding the CIP. And that's where we're offering it at this time. So how long does a SLM test take? So that really depends on what we're targeting. I showed you that map a little bit earlier on that was taking samples at regular intervals throughout a wash. And while that can be very useful, sometimes, in fact, I'd say most often, we're answering acute targeted questions, such as, is there soil that's accumulating in this wash? Is there a particular kind of soil? And is the wash measures and the chemistry that we're using fit for tackling that? In those cases, those questions may be able to be answered in a day. It can take couple hours to watch the wash and to process the samples, but getting back to that answer and being able to give a definitive recommendation can be pretty short. But if it's one of the longer full studies, we like to take our time and fully understand what we're looking at, and that can take at least a couple of days to fully bring to the field. However, we have increased the number of units in the field and improved the capabilities so that we can do this at the site of the testing, and that has increased the time significantly that we can turn this around in. Can this tell me if I'm not cleaning enough? So that's a question that we get sometimes. There is a variety of optimization tools that are very useful already for determining if something is not cleaning up properly, and we are very happy to use that and to help troubleshoot systems that aren't cleaning. This tool is not specifically the best tool for doing that. Primarily, systems that we already know are cleaning up properly are the ones that we want to use this type of optimization tool on, is finding those opportunities where they exist rather than trying to troubleshoot a system when we already have methods for doing that that might serve that a little quicker and a little better. What type of soils does this work on? So far we have used this heavily in the dairy industry. There are a couple of other areas when we're dealing with organic foulants that we've been able to look at. I have not heard of a membrane process where we cannot measure the soils in CIP. So if you have something off the wall, I'd love to talk to you directly, but I'm pretty confident we can find a way to test and measure how that soil comes off the membranes when we go into cleaning. And when is this going to be available? So this is available now. This is something we are offering to our customers, and we are familiarizing our account managers right now so that they can identify times and places in our customer sites where this is going to be the most useful. We're expanding this as rapidly as we can, and we want to be able to utilize this with anyone who wants to utilize this technology. So if you guys have any other questions, thank you for your time. If you want to come over to our virtual lounge, I think there's going to be some people there who will be able to forward questions on SLIM, or if you have anything other that's related to membranes and membrane CIP with Hydrite. Thank you again. I appreciate it. Take care.